Hello, my name is Carson Weber, and this is my final project over the IMDb movie dataset. Let's get started. So the first step was data understanding. So I went and described data and identified data types. So this data was collected from information of over 5,000 movies. The data consisted of many different variables, including the genre, IMDb score, the directors, actors, duration, language, and the country. There was a mix of categorical and numerical data, which we'll have to go through cleaning. So first was to get information on the types of data. We see there are a bunch of different types such as object, float, integers, and there's also many null data as well. So identifying data quality issues. So first we need to get rid of any missing values. And then after getting rid of the missing values, we're going to do this by cleaning the data, and I use this code from GitHub. This was the code here, and then this was the result. However, there's still some null data, so I went ahead and dropped all the NAs. And then I was just dropping variables that I did not think were helpful to the analysis, and then here as well, since they were objects. So the first step after data cleaning is regression analysis. The first thing I did was visualize the data. I won't show you everything, but this is just an example. This was the correlation between duration and IMDb score, and director Facebook likes, and budget. So this helped me see that at this point, the X variables that seem to affect IMDb score are the number of critical reviews for the movie, the number of users that wrote reviews, and then the number of users that voted on the movie, and then movie Facebook likes. The next step was actual regression. So I built two models. The first model will have all features, and the second model will have IMDb score, num critic for reviews, num users for reviews, num voted users, and movie Facebook likes. So this is the result of model 1. The R squared was 0.36. And then I made another model, and the R squared was 0.209. These were not super high. I next used lasso regression. I identified the Y and X variables first, built the first model with a higher alpha and fewer predictors. Go with the coefficients and the mean square error. And then I created a model 2. The next was a feature selection to find the most important features. This selected only 2 X variables, which were 1 and 6, which means they were duration and num voted users. F regression determined that duration and num voted users are 2 most important predictors. So moving on to model selection and building. The best model would be model number 3 of the F regression method because it was the most helpful, it had the most impactful variables and the highest R squared. This model takes into account the 2 most important variables. However, even with all the variables, there is still not a perfect model. So the next step was classification of the data, and I first did that by making a decision tree model. So first I set my own values for bins, 0 being bad, 1 being okay, 2 being good, and 3 being excellent, and I made the category of IMDb score, and this was just referring to if the score was bad, good, okay, or excellent. So after making this category, I declared the X and Y variables, did a split validation test, and then initialized the decision tree classifier, did a confusion matrix, and then this was the decision tree that was made as a result. So next was random forest, which just created 20 random decision trees. So this was the code here. And this showed the importance of each value. being duration, number of voted users. Next was KNN analysis. Evaluated the model by splitting into train and test sets to develop a KNN model, which had a model evaluation accuracy of 1, which is really good. Next, I searched for the optimal K value. And then logistic regression. This is the correlation analysis. And then this is data for ensuring the correlation analysis. There's a cluster map to show even further. And then evaluating the model. Next was clustering. So first, to do cluster analysis, I normalized the data and saved it as X. This allowed me to make different clusters. I did a variance test. K-means, clustering labels, centers, and then joining the two data frames. So then I interpreted the clustering analysis. In the first cluster, there's about 795, and in the second cluster, there's 2,961. So in cluster 1, the average number of critical reviews was 343, and the number of voted users was 296,870 people. The IMDb score average was 7 out of 10. However, in cluster 2, the average number of critical reviews was 120, and the number of voted users was 54,533. The average IMDb score was 6 out of 10. And this is just showing mean values for duration, visualizing it, and then for non-voted users, since these were important values. Next, I built a random forest classifier model for feature importance. This shows the importance of each feature, which num critic reviews being the highest, and then aspect ratio being the lowest. Finally, I did clustering analysis using agglomerative clustering or hierarchical clustering. This was visualizing the dendrogram, another way to look at it, and then through that, storytelling. So through this analysis, I found that the data shows the IMDb score is highly correlated to the number of critical reviews and the number of users that voted, along with movie Facebook likes also being important variables. Variables, however, such as aspect ratio and the number of likes an actor got on Facebook were not important indicators of a movie's success and should not be a point of focus. The data shows that in order to predict the movie rating, production houses will need to pay close attention to the response the movie gets on social media prior to its release. The more people that are actively involved in supporting the movie before it's released, the more likely the movie will be successful. Also, the movie profile of Cluster 1 seems to be most successful as there are more critical reviews and number of users who voted, which means the cluster is more likely to be supported or have more people interested in it. The end.